What about these kinds of graphs? How do we graph them and what are they called? Well, let's deal with that last question first. These are limacons. I know some people say limacons, but these are limacons. Let's see how to graph them. One of the things that makes these limaçon type graphs different is if you look at their equations, they have addition or subtraction as opposed to the roses. Limaçons can come in the form of convex, looped, dimpled, or cardioid, depending on the relationship between the A and the B value. Just like with roses, it also makes a difference if we're dealing with sine or cosine. If we're dealing with cosine, then the long part of our graph will always be horizontal. So it's all the long part, if it's cosine, will always go left to right if we're dealing with a cosine graph. So again, you'll notice that all of these have cosine. All of these are cosine examples. And again, the long part, which this is an example of the long part, that's what I'm talking about. This part is horizontal, same thing here. The long part on each of these is horizontal, again, because we're dealing with a cosine example. If we're dealing with sine, it's going to be a little bit different. So these are sine examples. Notice that on these, the long part is vertical. So the long part is going up and down. So if it's sine, the long part is going to go vertically or up and down. And it's going to make a difference if it's plus or minus as to whether it goes up or whether it goes down. If it says plus, these are all plus examples, the long part is going to be facing up. So here's an example that we can look at. What do we think this is going to be when we graph it? Well, these are both 2's. A and B are both 2's, so what could it be? Well, it's a cardioid. Some people say it looks like a heart, but almost everybody says it looks like a butt. But this is essentially a cardioid. So notice that when it crosses or intercepts, it's going to cross here at 2. And it's going to cross here at -2. So it's 2 away in one direction, and it's 2 away in the other direction. Basically, that value that we had, that 2, is what we're using to determine that. This length is the sum of those two numbers. So if we add both of those 2's, we end up with 4, which is always going to give us the long part. Pause it and take a guess what this is going to look like. They're both 3. So when we graph it, it's another butt. So when we go up, notice it's going up by 3, and it's also going down by 3 for where it crosses. So that 3 is going to tell us where it crosses. The other thing is, if we add those 3's, that's 6, and that's exactly how long this line is, this segment is. So the longest part on this one is 6. What do you think this one's going to be? Well, this time the A value is 3 and the B value is 6. So if we put A over B, that's equal to 1/2. 3 over 6 is equal to 1/2, and that's less than 1. So when we graph it, we're going to end up with a looped limaçon because it's 1/2 for that value. Notice that it crosses here at 3, and if we go further down, it's going to cross there at 3. So that first number is going to again tell us where it crosses. If we took the difference, so if we subtracted that 6 and 3, we'd get 3, which is exactly how long this inner loop is. So basically, if you subtract the A and the B value, that will always tell you how big the inner loop is. For the longest part of our graph, if we added those values, the 3 and the 6, we get 9. And notice that this one goes all the way out to 9 on the graph. Remember that for this function, we were doing 3 minus 6, which meant that we're pointing towards the negative direction. But what if we change that? What if we made it 3 plus 6? How would that change the graph? Well, it looks like if we change that to a plus, made it 3 plus 6, then it will be facing the positive part of our graph. So basically, if it's positive, in between, it's going to face the positive part of our